If you want to pump your body and expand your mind, there's only one place to go. Mind Pump. Mind Pump with your hosts, Sal DiStefano, Adam Schaefer, and Justin Andrews.
I have been waiting for us to release this episode.
Yeah, this was a good one, man.
This was a good one. This is the best episode we've done on probiotics, gut health, and the sciences that surround that. So for me, this was a very, very good educational and exciting episode. And we recorded this a while ago, and we couldn't release it because the company Seed had to get up a stock. They had run out of stock. So we had to wait before we could release this so that you guys could have access to their products. But we interviewed Raja Dhir, D-H-I-R. He's the co-founder and co-CEO of the company Seed. They are at the forefront of probiotic research. And this company, it's like an ecosystem of scientists and doctors and innovators. Among them, some of the scientists that are on their team is Chief Scientist Dr. Gregor Reed. This guy's one of the pioneers of microbial sciences. He actually chaired the United Nations and World Health Organization panel that first authored the global definition of the term probiotics, and he's on their team. So this is like the company.
It's the Michael Jordan.
It is.
Probiotics.
Now, Raja, who you're going to hear in this episode, is brilliant. Young dude, too. Absolutely brilliant kid.
Very cool guy, too.
Very, very cool guy. He serves on the editorial board for the scientific journal Microbiome and on the industry advisory committee for the International Scientific Association for Probiotics and Prebiotics. He's also a member of the New York Academy of Sciences, the American Society of Microbiology, and the American Association for the Advancement of Science. This dude is brilliant, obviously. You're going to hear in this episode. He's also a very good communicator.
Yeah. So
we really enjoyed this episode. And if you're interested in gut health and the science of probiotics and how they work and a lot of the bullshit that you hear with a lot of the advertising out there, what's true, what's false, you're going to love this episode. So
very informative episode.
Yeah. Now, this company, Seed, we are now working with them. They are the best probiotics that any of us have ever used. You can find them on Instagram at Seed, and you can find Raja Dhir himself at Wild RAJA. And if you go to Seed to get your probiotics, use the code MindPump. The site is seed.com/MindPump. Use the code MindPump without a space for 20% off your first month of the daily symbiotic. And again, we don't promote every single company that comes to us, but this one, by far the best probiotic company. They are the leaders in this industry. So without any further ado, here we are talking to Raja Dhir.
Raja, I want to hear about your background because you have a fascinating background. As I'm reading about you, go ahead and tell us a little bit about yourself. You're obviously not from California originally. You said you're from where? Atlanta?
Yeah, so I grew up in Atlanta. I went to high school there, and that's where I was enrolled. But I spent almost every other weekend or every summer traveling around the country, starting from the age of 13. So I was a very competitive national debater on the national debate circuit. I think I was in top 2 or 3 by in the country by the end of my senior year.
You got a scholarship for that or something, right?
Yeah, I did. College decision was really easy for me. I was offered a very large check by USC and recruited pretty much after my junior year. So kind of knew I was going to head to LA for undergrad. And then my senior year at that point, I'd completely checked out of academic, or I was still enrolled in all my classes and getting good grades, but in terms of what my interests lie, debate was taking the lion's share. And in fact, I think I credit probably the majority of my thinking style to competitive debate for 2 reasons. First is in tournaments, you have to do what's called switch side debate. So in any one tournament, you have to argue 2 sides of the same resolution, which on one hand makes you very good at critical thinking, on the other hand can make you borderline pathologic because you don't have any true convictions, or you can take an argument and separate any emotional attachment that one might have.
That's interesting you say that, because a long time ago, a friend of mine taught me to, if I wanted to know my side very well of an argument, I had to learn the other side just as well. And,
yep.
it did teach me to think differently, and it got me to really be able to argue my side because I would know the other side, really, and many times I would change my mind. I would actually end up finding truth in the other side that, you know.
Yeah, and so there's even been some early testing on. I mean, of course, we're in a political climate right now where people don't actually listen to what other people are saying, and what I think is really interesting is that if someone just is in a debate, is required to repeat the other person's question to their satisfaction. So if I understand it correctly, your question is, and then you recap it and make the other person agree that is their question, that it eliminates kind of the anger and the emotional charge and tension, because in a way you've, to a certain extent, acknowledged the other person's position, even if it's done, a little inadvertently. So I think that, those skills are really valuable, especially when you're looking at scientific health-related research. It's it's one of those few areas where everyone has an opinion, and people can look and cherry pick research in ways that in many cases support or confirm the argument that they're trying to make. And so it's even more important that I think people start to develop those skills.
How politicized is science and scientific? It's not supposed to be, right? It's supposed to be objective, but is it?
It's not. And there's a couple reasons for that. And by the way, I want to caveat that by saying it's more objective than almost any other discipline. But my point is that even science has, so you want to get a good publication, you need a cohesive narrative, you want to have high impact, your findings need to be novel. And so there's humans behind scientific enterprises and personal careers and prestige. The peer review process is a little bit variable depending on the field and the journal, and also certainly the credibility of the author going into a publication matters a lot too. I only bring that up to say I think that we just have to accept as a reality that not to cheapen the quality of scientific research in any way, but just that I think we have to take a lot of findings with try to look for reproducibility of results, be very data centric and data heavy, really ask people if they've considered the statistical models that they're using, if they've used the best models that reflect that, or if they omitted models that somehow were giving contradictory information. And so I think that the whole it is better than most fields, but there's certainly a little bit of bias, I think, as well.
Yeah, in our field of fitness and health, we're constantly bombarded with information that counters other information, and the whole fat hypothesis that the government based a lot of its food recommendations on for decades, which some people would say led to the obesity epidemic, although I think it's far more complex than that. It makes it. I think we're at a point now where a lot of people aren't trusting science like they used to, and maybe because science isn't politicized in the sense of the scientists, but I think politicians will take science and then politicize it.
Absolutely,
in those ways.
So there's about 3 or 4 key levels of dilution. The first is in the initial publication itself for the narrative. You have to just check to make sure all that's fine, and then God help us when we start getting to popular science and scientific press, because for some reason I think one of the areas that we're working and researching on is early infant health and maternal and prenatal health too. It's one of our tracks, and I think this was a fact that came up a couple of years ago that still stuck with me. There's more PubMed articles on coffee and tomatoes than there are on human breast milk, and I just think that's very strange. Yeah. I think that's a really bizarre fact.
Why is that? Maybe we can't sell breast milk?
People
because
love
not everybody's drinking it.
Yeah.
Coffee,
Good point.
dark chocolate, sex, and depression. Those studies seem to disproportionately get a lot more scientific press than a lot of other areas. So I don't know why. I think there's kind of triggers for...
Yeah, that's true.
A wine. Sorry, I should add wine to that list.
Yeah.
People love the going back and forth on the rationalization of alcohol being healthy.
Thank you. I'm so glad you said that. We get so mad when we get people messaging us like, hey, this study said that.
Yeah.
Drinking a glass of wine
It's
a day
all about
is
resveratrol.
Yeah, it's like doing 30 minutes of cardio. It's like, no, it's not the same thing at all.
Not at all.
Not at all. So how did you get into this into the sciences? You were in the debate.
Yep.
You're like a debate champion. What led you down the scientific route?
And the last thing I'll say on debate is that from the ability to go gather information, self-educate, and synthesize that information and connect previously unconnected dots is what the skill set that makes a good debater. And so you think kind of you can apply that in any rigid discipline, and this, like, taking it into the sciences and biological sciences in particular, I think is it's really interesting. So after that, I studied biology and philosophy in undergrad. I continued debating for my first 2 years, and my first kind of idea or trail for a company actually happened when I was in undergrad, and it's when I came across a study of a protein producing plant that had very curious sensory effects on the tongue, and so it temporarily would bind to receptors that were responsible for bitterness, and it would alter that into an acidity into the sensation of sweetness. And so I think that a lot of people would say, well, that's really cool, is either for diabetics or as a sweetener alternative. But I was particularly excited by a study that showed that for cancer patients that had just finished chemotherapy, they report having a metallic aftertaste in their mouth. And so it would mitigate that effect and allow them to return back to somewhat of a normal appetite after undergoing chemotherapy. So that was my first real kind of moment of what I call translational science or the applied sciences, where it's really nice when there's research that's mechanistic or speculative, and then that's one side of the whole discipline. And on the other side, there's people that don't care about the science but just want to push a product and get it out to market. But somehow that distance that between those two areas is really vast. And my whole career has been spent bridging that disconnect, and doing so. And I think the first iteration of it, in my first company outwards, was a company called Vitalamine, and our thesis was, well, if you could isolate micronutrients and standardized micronutrients from organic plant material, possibly even plant material that's unused in human consumption, so not kind of the edible parts, but kind of thinking about the whole biomass of the plant, then you can create a really interesting kind of efficiency scale with food products and vegetation and biomass. But that was a pure translational science play. Now I think what we're working on, which is even more exciting, is can you get the original scientists and the academic centers that publish that mechanistic and breakthrough work and see them all the way through actually to the finished trial development and productization itself.
How important do you think that is, to have the original scientists be a part of taking those examples and moving them all the way through the process?
And how rare is that?
Yeah, we can apply this now. This is how we can use it.
So there's a couple things that happen. So if you remember earlier, those levels of dilution, that's one of the biggest ones, at least when it comes to products and consumer health, right? Is a lot of liberties are taken. People reference public literature that's not on their dosage, that's not on their product, that's not on for microbial sciences on the strain, but at the species instead. There's a lot of, I think it's very important, and I think it's very rare. I think oftentimes scientists are either don't trust companies. They're not, for the most part, motivated by financial return. It's not what drew them into their field or area in the first place. And oftentimes there's a stigma attached to it. Oh, well, you're a scientist and you have a company or you're working with industry. Yeah. In some way, it's not worth the perceived bias, or reputational risk that comes with that. And so I think it's very rare. In fact, I know there's cases where companies will pay a lot of money to get kind of a scientific or medical endorsement. But I think it's very rare where incentives can be aligned and companies can be built with the right DNA, where scientists actually not only feel comfortable but actually very inclined to see their work through. In fact, when you can strike the right balance, it's actually really gratifying for the scientists too, because they'll say, "Look, we've been focused our whole career on this work, and we'd like to see it get to people."
Right.
If they're working on therapies that can impact a lot of people's health and previously unaddressed and unmet conditions, I think a lot of people are motivated by that. And scientists, doctors, of course, at some point or another, the primary motivation is helping people with their health.
So one of the things you're saying is that, or what you're basically saying is that you see a lot of cherry picking the science, right? Is that what's going on?
In terms of companies that that are product first,
right?
I think that is probably the biggest problem that I have with all the state of affairs in consumer health to date. It's that it's not really considered in a 360 way. It's really you pick something that supports the narrative that you're trying to tell.
Right, you have a desired outcome already, so
Yeah.
you search all the PubMed research and go, oh, this looks close enough to what I'm trying to say.
Yep.
We're going to use this study to support our claims for our business.
Absolutely.
Now, with that being said, are there certain things that really irritate you that you see right now? Like what comes top of mind right now?
Oh gosh, I think we got to narrow that one down a little bit.
No, I mean, there's got to be one that
Yeah.
ruffles your feather the most, whether it's be in your own space or something you see commonly cherry picked.
Yeah. So I have a really big problem with detoxification. I think that there is a detoxification pathway in the body. It's activated by a protein and transcription factor that is in the non-nucleus of the cell in the cytoplasm, and it's a transcription factor is just kind of there's about 2,000 or 2,300 of them in the body. It's just a protein that turns on or turns off genes. So that's all a transcription factor is. And there's one that regulates over 500 genes that are all related to detoxification, and it's called NRF2. And they're very clear things that either induce its expression or that dampen it. And that's detoxification. That results in your body producing a series of antioxidants, of binding proteins. I mean, there's a very clear process by which compounds that are toxins or toxicants are eliminated from the body. And so I think it's not going to be solved by a 3-day cleanse. It's not going to be solved by eliminating fibrous, nutrient-rich foods from your body and shifting over to a sugar-rich juice. It's not going to be solved by supplements.
Pads on bottom of my feet.
It's not going to be solved by pads on adsorbent pads.
But they turn dark.
Yeah, it's dirty afterwards.
Yeah. We can spend a whole thing on red herrings in health and science too, but it's even the biggest one that bothers me is people say, well, glutathione, that's your body's master antioxidant, so why don't you just take it exogenously? Why don't you consume it as a supplement? But that doesn't activate the whole pathway inducing the production of antioxidant and detoxification responses in the body. And so again, taking one endpoint or outcome of a system and assuming that just because that's the endpoint it's going to have the same effect as activating that entire system, I think is probably the thing that bothers me the most in terms of popular health and science. And in microbiome or more hardcore biological sciences, I think I have some other ones, but I think that's probably the first big myth that I have a pretty big issue with.
Such a good point. It reminds me of, for years we were told that having high antioxidant levels was will prevent cancer. So then they did studies with people who had cancer and they give them high doses of antioxidants. And it actually protected the cancer cells, and they got much worse. It also reminds me of, and we see this a lot with pharmaceutical drugs, where you have high cholesterol, take this drug, lowers your cholesterol, but the process by which your body's producing the higher cholesterol, why your body's producing more cholesterol in the first place, isn't being addressed, and so you still have a lot of these problems. So taking glutathione, that's the end result, but why the process by which your body's producing more glutathione, that's a very important piece that we're missing there. And if we ignore that, then you might end up with something worse.
Yeah, well, I think you hit it on the head, and I think it's worth spending a minute talking about cholesterol and statins too. So absolutely, I think that the last thing you want to do, people talk about good cholesterol and bad cholesterol, but there's only one cholesterol. It has a molecular formula that's very simple. The difference is how it's carried, and if there are markers for it that can either have a lot of downstream effects that increase your risk of a cardiovascular event, or protective because of the size of those carriers, right? The lipoproteins. But really interesting, just to focus in on that point you just made, a couple of weeks ago, a really interesting study came out of Switzerland, and they found that cholesterol-lowering medications, in particular statins. And again, this is another myth. It doesn't matter if it comes from red rice yeast extract, whether it comes from a commercial pharmaceutical statin. The mechanism is still the exact same. And we can spend after this talk about why oregano oil isn't good for you either, because it works like an antibiotic. And if you have it in high quantities, it's like you're taking an antibiotic, whether it's synthetic or not. But with cholesterol-lowering medications that block the body's production of cholesterol, there's a lot of other effects that happen. And of course, I think with humans, you can bore them with the science, but the best way to get them is play on their vanity. And so in this case, they found that cholesterol-lowering medications decreased brown adipose tissue, which is the good, in air quotes, kind of fat.
The thermogenic fat.
The thermogenic fat, which actually keeps you warm in the winter and doesn't increase your risk of metabolic syndrome and doesn't aggregate in adipose regions and result in obesity, right? And actually increased white adipose tissue. And so it stopped that same process of stopping cholesterol production, also stopped the browning of white adipose tissue and white fat, which we know is a very good thing, but also makes you physically less fat. I think that's something that if that can't motivate people, then
we actually talked about that on a recent episode. I'm like, well, you're taking statins, and over time you're making yourself fatter and not as healthy. Plus muscle weakening and all that other stuff.
Yep.
So, what got you into studying what I believe, in my opinion, to be one of the most fascinating and potentially most groundbreaking areas of the sciences for human health, the microbiome? I mean, I think that the more, as we understand more and more about the microbiome, I think we're going to be able to have breakthroughs in biology that are going to be unparalleled, in my personal opinion, especially with the types of diseases that we suffer from in modern Western societies, which are of the chronic variety.
Yeah.
What brought you to that kind of study?
Yeah, so my co-founder Ara has a really good point on this, where when people were really excited about the Human Genome Project, that was kind of the first wave of science where everyone said, okay, locked in our genome are the answers to health and sickness, and if we can understand that, then we can understand what our risk factors are and we can change health. But yes, there's CRISPR and Cas9 and genome editing, but we're a long ways away from being able to edit our genome. And of course, there's going to be a lot of downstream effects because we don't know, as of now, what small changes can ripple out across, kind of the lifespan of a human. But the reason the microbiome is so exciting is because you actually can modulate, manipulate, control, and seed and plant a certain collection of bacteria from a very young age, or edit and manipulate that very easily. In fact, we do it on a day-to-day basis with antibiotics. Mm-hmm. So the fact that this is a field which is related to nearly every organ system in the body, that patterns have been found between multiple serious disease states and changes in the microbiome, and the fact that its relative ease of manipulation is that perfect storm that makes the sciences so exciting. But of course, as I hype the field, I want to take a moment to temper it, which is just because we can show that we don't know which way it works. Does a disease result in a changed body conditions that allow different organisms to then therefore thrive, or do the organisms cause a result and perpetuate a disease state over time? It's too early to know that. And so something I always tell people is, yes, it's wildly exciting. It's probably one of the most exciting fields in science right now, and it's one of the most interdisciplinary fields of science. So you have gastroenterologists, you have immunologists, you have neurologists. I mean, cardiologists, everybody from different fields where it can be impacted by microbial sciences, all storming the field to see how the microbes or their metabolites affect their organ system, or the way that we've kind of carved up the body in modern medicine, and that's just an incredible foundation for good science. If nothing else, I think the field is progressing because you're just getting such an influx of brilliant minds.
It's crossing so many different specializations, and I'm not a scientist, so I can speculate all day long, and I'll speculate that the relationship between the microbiome and the body and disease is a two-way street. Yep. I think that's my hunch. My hunch is your conditions, your thought processes, the context of your life will affect your microbiome, and then vice versa. Microbiome. They're now connecting the bacteria to Parkinson's. There's a scientist who's offering $1 million to find a bacterial connection to Alzheimer's. Yep. So I think this is insane.
That's a really good story. There's a neurologist at Harvard Medical School by the name of Robert Moore, and Stat just did a really nice long profile piece on him. And for the longest time, people just so the Alzheimer's theory of aging, or the amyloid plaque theory of Alzheimer's is that for some reason or the other, the body produces these beta amyloid plaques that then tangle up and cause neuronal death, and that's always a bad thing. You don't want production of these amyloid plaques in the brain. It's something that's gone wrong, and if we can stop the production, then you can prevent Alzheimer's disease. So that's kind of the, quote, establishment position in Alzheimer's, right? Is that this beta amyloid theory of Alzheimer's. But his thesis is that, well, why are these amyloid plaques there in the first place? And if you look across all species in the evolutionary chain, you see that they're produced. And so usually what that means for evolutionary biologists is that there's some function that's ascribed to it that if it's either not important, it's protective. It's certainly not something gone haywire, right? It's certainly not an anomaly or an aberration that this is happening. So he took that as his founding principle, and he went deep in and started to find connections. And for the longest time, I mean, the establishment, all of his grants were rejected. The NIH said this is absolutely not possible. And this is a Harvard neurologist. Finally, his thesis and two really high-profile studies in 2011 and 2012 respectively came out from his group that finally put him on the map. And they showed that their thesis that these amyloid plaques are part of the brain's immune system that protects against microbes or bacterial metabolites.
So some kind of an insult.
So the thesis is that, and this is something that I think that in the coming years we're going to find, when barriers break down in the body, I think that is the start of a cascade of a lot of degenerative effects. So whether it's the intestinal barrier, whether it's vasculature barriers for atherosclerosis or cardiovascular disease, or whether it's the blood-brain barrier for neurodegenerative conditions, I think a lot of problems start when barrier disintegrity begins. And so certainly what prerequisite to microbes or bacteria in the brain or microbial metabolites are
there's a breakdown of the blood
breakdown
barrier.
of the barrier.
Yeah.
Maybe. And another study, and so this is a really interesting one that's was one of our company posted at the end of last year, that some of the 10 really, most interesting things in science that we think happened that year. And one of them was actually, it was a small poster at a brain conference in San Diego, but a group in Alabama of all places did brain tissue electron microscopy, and they found a lot of these small little rod-shaped organisms that little rod-shaped dots on their scanning graph that they just ignored, or people have ignored it, but finally they just, I guess, looked at it with a fresh set of eyes, and they believe that they've found bacteria colonizing the brain of healthy individuals, that we actually don't have a sterile brain. But
because that's the old belief, right? That it's sterile. There's no bacteria in there whatsoever.
And here's the point. You wouldn't. It defies everything that we think from a systems perspective about the body, right? Why would the body allow any? I mean, bacteria can manipulate and change their function and their genome so quickly. That's something that's a lot more, from an evolutionary perspective, static, right? Like the human genome. Why would we permit bacteria, regardless of whether this particular organism has a history of being friendly, to colonize these highly sensitive environments, places like the heart, places like the brain? You wouldn't want it. I got in a really interesting discussion with one of the leading microbiome scientists last year when I said I think that there's bacteria in breast milk. I think that bacteria migrate, not glycans and oligosaccharides, or these base materials that grow bacteria in a developing infant, but actual organisms that migrate from the mother's gut into breast milk itself. And these are not organisms that have colonized kind of the nipple or the milk duct, for instance.
It's actually in the milk.
I think that's, I'm actually, last year I started putting together a protocol to actually look and see this by actually using isotopes to tag specific bacteria, so you can indisputably say it's this bacteria that migrated. I think I put it on hold, but I think that's a really interesting study. But it goes back to that point, which is, why would the body allow? We know these organisms that hitch a ride or are opportunistic By the way, even good bacteria are opportunistic. They're not good or symbiotes for us because they have good intentions. It's the right system that is working for both parties right now, that over a series of evolutionary cycles is permissive. And so it allows them to be there and allows them to colonize.
It's no different than when you see the videos on national, like Blue Planet, where you see the shark swimming and there's the fish stuck to the side of it. Yeah. That are just eaten, off the, like they both help each other. When did that change in science? Because when germ theory first came out, it was an all-out assault on these microorganisms that we had just discovered, kill them all, disinfect everything. Antibiotics were given out like candy. When I was a kid, in the 80s and 90s, you go to the doctor with anything, and they would just prescribe an antibiotic.
Yep.
When did that start to shift, where we started to look at it and go, oh, wait a minute, this is a mutually beneficial relationship. We shouldn't just destroy everything.
Yeah. So I think that I think it's be helpful for people to even understand the field of microbiome science, where it began, because it answers that question, I think, really elegantly. Okay. No one believed that bacteria to this extent were beneficial or protective, even as recently as 2006. And so before that, the term microbiome was used in a couple small circles, but it wasn't blue chip academics, and it wasn't the kind of gold mine of a field that it is today that's really attracting some of the world's top scientists. And in 2006, what happened was scientists at the Washington University in St. Louis in their medical school published kind of what I call the shot heard around the world, which was they took obese mice and lean mice and they used antibiotics to knock out their microbiota and then transplant the microbiota of the other organism. And consistently they found that after doing that, their whole phenotype changed. So obese mice became lean very quickly, and lean mice adapted an obese phenotype very quickly too. And so again, it kind of goes back to our point earlier about if you want people to listen, just play to their vanity. But that was really interesting. That was the first idea that people said, well, look, these aren't just commensals. These aren't just kind of hanger-ons. These are really kind of systems affecting organisms that live intimately and closely with the human body. But if you go back to even literature and smaller literature in the late 70s, early 80s, people in publications were talking about the fact that there's this community that has a close relationship with the human body. I mean, people have been theorizing this for a long time, but the field really picked up traction, I would say, from 2006 onwards. That resulted in the Human Microbiome Project, which was a NIH-funded, $150 million research initiative that wanted to take 5 body sites in the body and characterize what is a healthy microbiome. Just one simple question: what is a healthy microbiome? And if we take enough samples from a couple hundred people and deeply analyze and sequence it, we'll start to see enough patterns to know what one healthy microbiome is across all of these different types. We'll get back to we'll get back to that in a second, but spoiler alert, there isn't one healthy microbiome. I was
just going to say,
it's like a fingerprint, right?
Yeah, there is not, and that's because there's what's called scientifically a high level of functional redundancy in the microbiome. So one species or one genus isn't the only one that does that job. There's a lot of other ones that can do that job. And so you really have to look at function, not kind of the identity or the genomic composition or even the transcription of those organisms. And so that initiative happened, and then Human Microbiome Project 2 came shortly after. And then it combined with both the cheapening of sequencing technologies and the number of researchers around the world that are starting to publish now and review each other's work. And then the field kind of hit a critical, a tipping point, I think, in 2011. It got a hype cycle, it got a bust cycle, and now it's kind of somewhere in between, where there's still no FDA-approved drug or therapy. And we have 3 in our pipeline that we're targeting that are going all the way through FDA phase 3, trialed. I mean, the highest level of rigor to make drug claims. But there still to date is not a microbial, a bug as a drug that's been approved or made it all the way through phase 3. And there's a lot of people that are kind of taking the term and making it a new buzzword, right? It's like what antioxidants were. It's like what detoxification was in some circles. I think ketogenic is. I think we we all know that there's certain studies in some areas that are very beneficial. The question is always, over long-term studies, has this been shown to not only be safe but effective for a generally healthy person? And it's really hard to answer that question. And kind of to go back to your question from earlier about things that bother me, I have a real big issue also with longevity research, because I don't think you can properly design and power a trial that is less than 50 or 80 years long and needs tens of thousands of people, and you can't control appropriately for every variable, so it has to overpower all of the confounders, which doesn't really help. I mean, that's either makes people skeptical, and so they say, well, this field is just all pseudoscience, or it makes people say, well, we don't need to do a properly designed trial because all we have to show is that we know the mechanism.
Yeah, it reminds me of how, I'll use an example, and maybe you can you disagree or agree with me, but it reminds me of how we pass certain things to become legal, for example, or be able to be used on our food. For example, glyphosates, how they're sprayed all over food. When we studied those, we didn't study their effects on bacteria or microbiome, mainly probably because we didn't really study those things at the time. We're not going to see how it affects your microbiome because we don't know much about the microbiome, or maybe we don't study it at all at this point. And now we're at the point where people are saying, hold on a second, glyphosates may have some effect on, if not the bacteria in your gut, at least the bacteria that's in the soil. And we don't know what that means, or it may be a bad thing. So it kind of reminds me of that. What are your thoughts on glyphosates, by the way? What is the research showing so far?
Yeah, so I mean, clearly so first to start off, everything affects the microbiome.
Okay.
So even changing your diet in as little as 48 hours will have a noticeable or detectable effect on your microbiome.
Can't your mood even change it, right?
Your mood can you can generate changes. Stress can change it. Cortisol production can change it. Rigorous exercise, high intensity interval training can change your microbiome. High fat diet can change your microbiome. Different compositions of amino acids and proteins can change your microbiome. And that's just your gut microbiome. If you look at there's your oral microbiome that's in your mouth. There's your skin microbiome. Women have a vaginal microbiome, which I think is incredibly important. It's one of the research tracks of our company on having systemic effects from everything from fertility to urinary tract infections to bacterial vaginosis to menopause. I mean, this is that's a primary line of defense. And so all of these systems are intimately related to the body, and they're constantly changing and evolving. So the first point I would make is, yes, things change your microbiome constantly. My theory on any particular toxicants in regard, like preservatives or synthetic fertilizers or foodborne agents, is I don't think that there's enough longitudinal research to deem them safe. I think that concerns around their toxicity are usually at doses that are far higher than what's found residually on human foods. I think that the bigger problem or effect with it is on the plant and the soil itself rather than on the human body. But the point is humans have a very rigorous and in-place detoxification system. The few things that do overpower it are organic and inorganic metals, dioxins, and PCBs and dioxins that aggregate in tissue over long periods of time and are very hard for the body to eliminate. The excess minerals.
Okay.
Anything that aggregates and is stored in organ or is stored in tissue long term that has systemic effects are my biggest concerns. I think that anything that doesn't aggregate in tissue, and I don't know the research whether glyphosate in particular aggregates in tissue, but my hunch is that it's not good for that. It, along with the whole suite of compounds that work along that system are not good for the human body. I believe that there's probably worse things that you could add or spray onto foods. I think that, of course, the ideal is that don't replace it with something else that's also preservative, that's worse. And I think that that's something that's missing a lot from the equation is, of course, if you're looking at it compared to having no, what is it? It's in microbiome science, we call it xenobiotics, or just any compounds that are foreign to the body that are interacted or detoxified first by the microbiota and then by the human host. It's better to have none. But then don't look at it in a vacuum. Look at what you're replacing it with. And so to the extent that the alternative to that in the food supply is something that aggregates even more in the body, then that wouldn't be a good thing either. But of course, the gold standard is try to eat food in its original form with as much of its, existing soil and microbial load as you would find from a condition. I think that's fairly well validated.
Yeah, the way I explain it is it's we co-evolved with these foods for a long time.
Yep.
And so we introduce new things, new products for how long? 50 years, 60 years, 1 or 2 generations at the most. We don't know what that's going to look like down the line.
Yep.
And now we're learning that and again, this is your field, so I'd love to hear more about this, how our microbiomes are passed on to our children, especially from the mother to child. And I've read some studies that show that the diversity is less and less now through the generations, and people are trying to connect that to food allergies and autoimmune issues. I mean, when I was a kid, I don't remember a single kid in my school who had a food allergy, and if there was, it was like really rare, and they were like, oh, that's the kid over there with the food allergy.
Yep.
Now, like entire classrooms are peanut free.
Yep.
At my kid's school, there's 3 entire benches and tables in the lunch area that are allergen free.
Yep.
3 huge. So this is it's grown exponentially, and it's not. We didn't evolve this way. There's something that's going on. Do you think that has to do with
Could there be 2 factors too, with the not like breastfeeding not being like as prevalent, and also C-sections, things like that?
Yeah, so there's a lot of questions in there, and so I want to recap it just in case so you can remind me. First is how food has changed.
Yeah.
Second is transmission of the microbiome from mother to infant and its relationship to allergies. We'll add anything else to there that you want, but I want to the last point I want to make on how food has changed is I certainly am a big proponent of eating food in as close of its natural form as possible, but you got to look at those pictures and the data on how humans just through selective breeding have changed food
big time
just through farming. I mean, look at what a carrot looked like. A
banana
or a banana. I mean, these were scrawny little, primarily stalk with very little edible components that we've over time and generations of breeding, cultivated or picked for genes that are better for size or better for colors.
I saw a painting from the 17 or 1800s of fruit, must have been in the 1700s or even 1600s, of fruit, and the fruit was like sliced in half, and they were apples, and they had like massive seeds, and it was very little flesh, and it's like, oh yeah, we've definitely turned these things into sugar bombs.
Yeah, so that's one example of cherry picking. Like, yes, people that are proponents of natural, paleo, organic, as close to its natural form are they're absolutely correct. Yes, that is beneficial, but we've also made food a lot better. We've made it a lot more nutrient dense and rich. We've a carrot tripling in size and having higher levels of pigmentation, has higher carotenoid load, has more antioxidant value. I mean, these are the more room for minerals to aggregate. Like, human intervention in general, it's a two-way street. It doesn't always mean it's bad, doesn't always mean it's good. We just need to take a step back and not politicize or charge it and just look at what we've done. Another really good example for me is wheat. And people look at, genetic modification of foods, for example. I mean, every wheat plant and corn plant to a certain extent, and actually every vegetable has been genetically modified. It's just been done non-specifically. So either it's been through selective breeding, or it's done through even a worse process of mutagenesis, where you'll just hit the genome with something that results in large genome-wide changes that are uncontrolled. So that's crazy to me, that you can be affecting hundreds, if not thousands, of genes spontaneously, and then just watching and observing and saying, oh, well, this one looks like it's better, let's move this one forward and advance it. I mean, that is the history. Please go research the history of selective breeding and mutagenesis of foods in the last 50, 60 years. And so to then just it's almost like at the very last step, you then say, oh, well, now I don't want something that because some company went
what this did.
and changed one gene out of thousands that literally made it reduce kind of the production of a toxic component, or that prolonged its freshness, or that made it naturally unattractive to insects instead of having to use preservatives or spray-on agents like glyphosate. So usually this whole story is a lot more complicated than that. In many ways, selective genome editing solves the issue of having to use synthetic spray-on preservatives or insect repellents, because you just do it with the change of addition of one specific gene. So I really want to. I know that this is like kind of blasphemous to go into this territory, at least for a lot of people. But before everyone lashes out, I just want to say, whether we changed it or whether it's indiscriminately changed, there's been a lot. Everything we eat today has been changed, and so I think that one thing that helps people put a lot of the politics around food and health in perspective is taking a longer view. Don't look back in the last 5 years and the last 10 years. Look at things across the last 100 years or last couple thousand years and these patterns. And certain communities evoke Paleolithic or ancestral eating habits. But then again, this is an example of then turning a blind eye when it comes to like another thing. And since you gave me permission to talk about things that bother me, I'll keep going back to it. Like in the paleo community, you can turn on things that are Paleolithic, but how about things like mattresses or hot showers? I mean, if you can't cherry pick what you want. Either the whole system itself works, or you have to say the food that we have today has been changed. Let's use science as a lens to mitigate those changes and select for ones that are actually beneficial. All of the foods that people love today in the health community are part of the Brassica genus. When Brassica first came about, it was this small little green, pathetic little leaf, right? So mustard, cauliflower, kale, broccoli, all these are part of the same Brassica genus, right? So I think that, you can't. Good luck for a Paleolithic person getting to eat any of this stuff, which is now cited as kind of the gold standard, is like the dark leafy greens. There was never dark leafy greens. There was one dark green leaf at some point. So, anyways, we'll put a pin in the food stuff. To your next question about allergies. Yeah, you're absolutely right. We have a research track in our company, and one of our most recent hires is from the immunology, one of the world's leading immunology labs at Harvard Medical School. And what their recent patent and publication, it's actually coming out in a couple months in Nature Medicine, is on the mechanism by which we can now show food allergies are caused and reversed.
Oh, wow.
And so this is, and I'll give you a hint, it's microbiome and microbe mediated. And so I will tell you absolutely that there may be a microbe, there may be a microbiome transplantation, there may be the avoidance of antibiotics, or there may be a small molecule or a drug or a metabolite. But if we can protect that specific pathway that alters the inflammatory profile of T regulatory cells, T helper cells, through one specific pathway, in animal models now, we can not only prevent the occurrence of food allergies, but we can totally reverse it in mature adults.
Wow, that's fascinating.
It's huge research. Stay tuned. 2019, our group, researchers and scientists at our company, and areas and IP that we are working on are going to be making a lot of announcements in 2019, particularly around food allergies. I think it's one of these areas that if you ask microbiome science, it's sensationalized or it's not sensationalized. This is one way I can tell you, in the next 2 or 3 years, we will make dramatic shifts and changes in our understanding of specific food-borne antigens and the body's immunological response to those food antigens. Or just food-based components, and hopefully be on track for therapy. I mean, I think prevention is the first. If you can take developing infants and monitor these systems, have a new diagnostic tool to look for that, especially if someone's at risk, or if someone was born through cesarean section or given a lot of antibiotics, then you can prophylactically administer or give. First, the earliest and most primitive version is you give a consortia of microbes, which that just means a community of them. The next version is you can do a specific probiotic. If you think about it, is just one organism that induces that pathway. And the third is, what if you could just take the microbe out of it altogether and just make microbes ferment and produce these compounds that you purify out, and that's all you end up needing. So you don't need, so it's reproducible and it's purified.
Interesting.
And that's, I think, a really interesting area. But to take it home, absolutely, allergies in particular, without a doubt, have a microbiome component to them.
It's fascinating because it's like a first world problem. You don't see a lot of these issues in underdeveloped nations. It's like, this is what's happening in Western society, and it's exploding, and it's crazy, and it's scary. And the good news is, I think there's a lot of money behind trying to solve this problem, because I mean, how much money goes into producing certain foods? Like, you don't want a whole swath of the population who can't eat your product because they're allergic to peanuts, or they're allergic to wheat or whatever. So, very
right. Let's go back to your vagina studies.
Yes.
This is some of
not my vagina.
This is Justin's favorite topic right here. So, what are you finding out about the bacteria in the vagina? Like, what do you know about that from your research?
Yeah. So, unlike the gut, which is a very diverse ecosystem, and understandably so. So there's the majority of the the majority of the microbes that are found in the human body are in the gut. It's a complex community. As we talked about earlier, it has high functional redundancy, so a lot of organisms in there, that many of which can do the same role. Contrary to that ecosystem, the vaginal microbiome is actually very narrow, has a narrow spectrum of microbes. And no matter what population, where in the world you are, or how you were raised, the vaginal microbiome is dominated by lactobacillus. In particular, underneath that, there are 4 species that are dominant types. So the first and most protective is a species called Lactobacillus crispatus. After that, there's Gasseri, Jensenii, and then the fourth is called a type 4, which is just a mixed community. And that's not dominated by one particular organism, but you actually find a high crossover and coexistence of
the other 3,
of all of these kind of communities together. And that's particularly found, or it has a higher prevalence in people that either have bacterial vaginosis or a disrupted vaginal ecosystem, or in, and it's very interesting when you start thinking about personalized medicine, or how you can cluster people based off of, kind of ethnicity or race. African Americans are able to have a type 4 population that doesn't have any negative health effects. So they have a more permissive ecosystem for more diversity without it having any downstream health effects. So in general, you'll find an ecosystem that's dominated by lactobacillus, and for the majority of the, world, it's a type 1 or type 2, so crispatus or Gasseri dominated ecosystem. And our studies are really interesting. So, a lot of the acidity, of course, the acidity in the vagina comes from lactic acid production. These organisms utilize glycogen, which is provided and is in close proximity with the vaginal epithelium. They lower the pH, they shuttle sperm towards the egg to aid in fertility. That's something that no one's really discussed, I think, or it's not a very common fact, is that lactobacilli actually are a prerequisite for sperm to enter into an egg.
Do we even look at the microbiome of the vagina in the terms of fertility? When you go to a fertility doctor, is that one of the things that they look at?
Nope.
Wow.
They don't.
You would think that would be so important.
It's very new research.
Interesting. Very interesting.
Very, very new research. And then most importantly is there's kind of a bad guy that's called Gardnerella vaginalis. And this is this organism induces an inflammatory response. It produces a fishy odor. It displaces lactobacillus. And it also can increase your risk of sexually transmitted infections. And so that whole constellation of symptoms is called BV, or non-specific bacterial vaginosis. And about a third to a fourth of all women have it at any given point in time. And so it's a really big issue. But of course, women's health issues aren't discussed publicly. Of course, there's a lot of stigma historically around that.
Sure.
And it's a new field. So I think the confluence of those 3 factors means that this is very under-discussed research.
I got a question around that.
Yeah.
The use of feminine hygiene products like tampons, which many times have maybe chlorine in them or chlorine residues because they're supposed to be made in a particular way. Can that theoretically then affect the microbiota of the vagina? Yeah,
absolutely. And the answer is yes. So do antibiotics. Antibiotics that enter into circulation change the vaginal microbiota pretty dramatically. That's my the bullish side of the answer. My caveat to that answer is that so does menstruation. So when a woman is in menses, you oftentimes find lactobacilli levels drop and go down because that changing ecosystem, the influx of all of the new biological fluids are not a system which is generally favorable for lactobacilli. So you see in the graphs, a drop goes down during menstruation, and then about 3 to 4 days afterwards, if you have a good profile or dominant and strong and resilient lactobacilli, then it spikes back up and it goes back up. So actually in our treatment, in our research track, the primary screen, one of the 3 screens that we use to pick protective organisms, specific strains within these species, and these are strains that were observed over 10 years of research. And what's interesting about our research is that we've actually seen these women come back in the clinic time and time again. Our chief scientist in that track of our company was actually the leader of the vaginal microbiome site for the Human Microbiome Project for the NIH. So starting with the HMP Human Microbiome Project all the way through, his lab has done and published more work on vaginal microbiome than I think the next couple combined. And so what we screened for primarily was these are women that even during menstruation, even when these women are on their period, the lactobacilli levels remain high. So these organisms are so resilient and hardy that they can stay in elevated levels and colonize even during that period of time, which we think is a fascinating attribute, which you don't find across a population.
Have you been able to correlate that with their fertility, or have you been able to correlate the rise in lactobacilli bacteria with ovulation when a woman is obviously
We've been able to correlate by looking at the following these women over 10 years. We know that these women the last part that makes this so interesting is that these women had every risk factor that you would look for vaginal disruption, low income communities, high antibiotic use, alcohol consumption, multiple sexual partners, having unprotected sex with multiple sexual partners each year. Poor diet, everything that you would look for. And despite that, have a metabolic readout of this vaginal microbiota that's pretty
interesting,
pretty incredible in terms of every marker you'd look for, every attribute you'd look for in a protective organism. So I think fertility was one part of it, but this study was focused more on and the last is they did not get over that whole period of time a single sexually transmitted infection.
Wow.
So they didn't get bacterial vaginosis. So the frontline defense, certainly against bacterial sexually transmitted infections, is that vaginal microbiota. And now we're starting to think that there's even mechanisms by which they protect against viral sexually transmitted infections, namely HPV.
Holy cow.
Yeah.
I want to take you back to when you're talking about the barriers, like in the gut lining and amyloid plaque. And are there ways that we can benefit that and things we can do with our diet or, stress wise, whatever it is to sort of benefit that?
So I can't comment on it for blood-brain barriers because I think that field is really very new. And it's very invasive, so it's really hard to test, and we don't really know much about the brain to begin with. So that part's really hard. I think in 5 years I'll probably have the same answer. In 10 years my answer will probably be different. But to the extent that nothing's entering passing your blood-brain barrier through absorption through your skin, right? It's the only source of entering into circulation is usually what's the first barrier, which is your intestinal barrier, and that's something that in more nutrition communities they call it leaky gut or barrier. In more mainstream scientific communities they call it intestinal permeability or barrier disintegrity, but it's all really speaking to the same premise, which is that you have a temporary or non-temporary breakdown of epithelial cells, and in particular, these tight junction proteins that sit in between them. So imagine your gut lining as a series of, non-perfectly meshed shapes. So think of like a pentagon or hexagon or something. And those intracellular space is filled with these tight junction proteins. A lot of things, everything from alcohol use to high intensity interval training to antibiotics also in some cases to certain foods have a loosening of that barrier, a temporary loosening of that barrier. In some cases, it could be good. So the question from an evolutionary perspective, someone say, well, why would high intensity interval training be bad for me? We know exercise is so protective. I mean, one could hypothesize that if you were doing something in that intensity, that perhaps it's advantageous for the body to temporarily get clues as to what's happening, what you're ingesting, what the foods are, what's happening in your external environment. And so it would allow for a access to that system, to your immune system for a very short period of time, right? So that's the furthest you'll hear me hypothesize. There's no scientific research to support that.
I wonder if it speeds up the assimilation and absorption of just nutrients. Your body may want to improve the speed by which it's recovering.
I never thought about that, but that's a really good theory. But I think one of the biggest perturbations, like NSAIDs, have an effect on your barrier integrity. Synthetic sweeteners do. Certainly, a lot of pharmaceutical and xenobiotics do. I would hypothesize that insecticides of all varieties, including glyphosate, do. And in fact, in some instances, you know that they do because you can find it circulating in serum in animal models, and human tests afterwards. You can find it circulating in blood serum. But there are things. The good news is that there are things you can do, and this is still an early field. And so, again, I don't like when people just say this is for leaky gut. We don't know that, but we know that there are things that organisms and compounds that you can induce which have a noticeable and detectable effect on strengthening barrier integrity. And there's a couple biomarkers you want to look for. You want to look at zonulin, you want to look at lipopolysaccharide and LPS binding protein. In some cases, if it's an animal model, you can do a biopsy and look at the structure of the tissue itself. The gold standard still continues to be these large molecule sugar tests where you give them a mannitol or a lactulose and see how much of it seeps into the bloodstream, because that's something that normally shouldn't be entering into the bloodstream. But we know there's things that have now come out of double-blind controlled trials that have an effect on this. That's one of our first product is a consortia of probiotic bacteria, and that's one of the tests that we ran. Is can we induce the expression of these tight junction proteins to help actually mechanistically stitch up that gut lining? So in some instances, bacteria can do it. Very specific bacteria can do it as well. So
I remember maybe 10 years ago, it was people from the wellness industry who were talking about leaky gut syndrome, and people from the medical industry were laughing at them. Yeah, and then they came out with their own term, which was intestinal hyperpermeability.
Yeah,
it's the same thing.
So you see it a lot. I think it's something, especially if you sit in between the two communities, which oftentimes can feel like they have our ships passing in the night. You see that people try to use the lexicon and the words that make the most sense to them, that intuitively try to grasp at something. I'm not giving that a pass, because I think that's, people should move towards more, in general, more scientific. You should push themselves to kind of understand what a trial is and what a control is.
Yeah, what I think that happens is it gets observed by people who work with a lot of people, like wellness coaches or health coaches or trainers, and they work with a lot of people, and over time they notice patterns. And they'll say, okay, this is here's the symptoms of that I'm seeing in all these people, and all these people are high stress, all these people overwork, don't get much sleep, and this is what ends up happening to them. And I'm going to call it adrenal fatigue, because it looks like their adrenals are getting fatigued.
Yep.
And then later on, science looks at it and says, well, no, that's not what's really happening. It's HPA axis dysfunction.
Yep.
But that doesn't mean the first guy was wrong. It just means that they were throwing, like you said, they're trying to name it something to make sense. And so,
yeah, look, there's a certain playbook. It's have some undiagnosable or multifactorial condition, health problem at a young age, some personal story, or be really, really obese and fat. then go and scour the literature and make systems changes to your body. You start eating healthier, you start exercising more, you start eliminating toxicants, you start observing and doing a whole suite of upgrades to your existence, and then going back and trying to find the things that made the most sense to you and attribute causality to it. Like that, you see that in every health story. It's the same narrative, right? And I'm not knocking it. I mean, what at the end of the day, whatever someone's journey is to make them, that makes them healthier, at the end of the day, that's the most important thing. I mean, you could say the same thing with religions. I mean, people use different stories and narratives to try to access and attain the same level of understanding about our role or our significance and meaning. I think that biology, as in terms of its spirituality, is far more beautiful than any of the myths and stories that we've come up with. But that's the story for another day. But it gets everyone to the same place. It makes them comforted. It gives them a sense of meaning and purpose. They can attribute some sort of, they get agency. They get to be the actor, the protagonist in their own story. And I don't mean that that's good or bad. I just think that objectively, if you look at the life cycle of any and most people that, have a theory about what happened in their health or what didn't, it usually follows that same path. There's a personal event that triggers a renewed understand, or as a catalyst for you to go and learn and absorb and synthesize the research, or something that happened to a family member or loved one. And then you go and you flood the system with a lot of information, and then however your modality of learning is that you've acquired over the course of your lifetime, you end up it settles in, and then you build a theory and you build a belief system around the parts that end up resonating the most with you. And that whole journey can take anywhere between 1 and 20 years, and can result in people coming out on the other side with, and name any one of the popular interventional periods, but they all kind of take you to the same place. Again, just like I think most mainstream religions do, they take you to the same place.
And a lot of it drives science. And what I like to see, what I mean by drive science is it leads to research then, because when there's enough anecdote, I think then scientists will say, okay, we need to look at this.
Yep.
And what I get excited about now is with, technology like the internet, anecdote now can get pooled in such massive ways. Like, I'll give you an example. I have a cousin who has Crohn's disease.
Yep.
And when he first got diagnosed with Crohn's disease, there really wasn't any information on diet. Like, what kind of diet's going to help him? There wasn't much at all.
Yep.
My aunt, being a very intelligent woman, went online and scoured the internet and found these forums with tens of thousands of members, which normally you would not be able to run into that many people who have Crohn's. But because the internet allows them to come together, there was all this anecdote about a diet called the carbohydrate-specific diet, and which now has become part of the protocol. But what drove it was all this anecdote from all these people who are observing and talking about it together. And so that's what I get excited about today.
Well, and just to clarify, in case it sounds like, that for me, that comes from a place of knocking it or thinking that science knows better or I know more. I mean, I think that what you're just describing is actually citizen science. It's the process of observation. Something has to hit critical mass in order for. I mean, science isn't just this kind of top-down agenda which says, okay, this year we're going to address this, and this. A lot of these things, in many ways, a lot of breakthrough research, I can point to a number of examples, surface and come as a result of this process of building a hypothesis, testing it, observing the data. I mean, at the end of the day, that's all science is.
Yeah.
And so there's nothing wrong with if someone doesn't feel well or if someone is sick. Oftentimes, the medical system isn't equipped to deal with or discounts it or says, well, it's either in your head or it has to get worse before we'll treat it. And there's that whole middle ground which is underserved, and there's a good and a bad. The good for that is that it gives people agency to go and find the solution that works best for them. The bad is that it creates an environment where the infrastructure is such that some bad actors can slip through.
Oh, so many
can slip through. And so that's all I want to say is that it emphasizes the importance of being critical and giving people agency and the tools they need and education they need to understand what or the right resources, what's legit and what isn't.
It's literally that saying in Spider-Man, with great power comes great responsibility. I think with the access of all this information, you have to become more responsible with how you sift through it. I mean, the use of CBD to treat epilepsy, that was driven by lots of people's anecdote on the internet. And then you got pharma companies now looking and making drugs.
Well, it's past a phase 3 trial.
Right, Epidiolex, right? It was from GW Pharmaceutical. Yeah. So I find that all fascinating. I did want to go back for a second. When you were talking about the importance of the microbiota of the vagina, I started to think about how, obviously, when a woman having sex with a man, how much of our microbiome is transmitted or between partners?
Yeah.
Do they start to match each other because we live in the same house, we have sex with each other?
So I will say that one of the understudied areas of microbiome science is the penile microbiome. So I can't point to a lot of those studies, but if you go back to my earlier point about the things that get a lot of press, the coffees and the wines and the sex and stuff, I think we should do that study because I think the whole world would be talking about it. But it's the point is that in any ecosystem you want resilience. And so while there might be a temporary disruption or transmission between those ecosystems, my hypothesis and what I know about the longitudinal studies in the vaginal microbiota is that once you have one, it tends to remain pretty stable. So the ecosystem is such, and there's a reason why every vaginal microbiota across the world is dominated by lactobacilli, because that is the organism that best serves and protects that ecosystem.
Because it works.
It works. And so, if a foreign agent, all these sexually transmitted infections or hanger-on pathogens that come through have hijacked that system to allow permissiveness or are just through brute force able to persist. The research suggests that a healthy vaginal microbiota is fairly resilient and stable.
Okay.
That it would rebound after a certain period of time back to somewhat of its original state, and you can see that because through various life stages it changes. During adolescence, once menstruation starts, it changes completely, and then when menopause starts, that ecosystem begins to change. So there's life stages that impact that ecosystem. But in terms of transmissibility, I mean,
yeah, like you have a roommate. It doesn't even have to be someone you have sex with, but you live with someone.
Yeah.
You share the same bathroom, and sometimes you drink from the same cup and stuff like that. Is there any evidence that, this guy's got a bad, he's got bad gut issues because maybe his microbiome's a little off? Am I gonna maybe inherit some of that because we're
So there was a study that looked at people that lived in close quarters and the shared similarities of their microbiota. I think it was more focused on couples and family members that live together. And couples that live together, I think that it wasn't the vaginal or it wasn't the sex organs and it wasn't even, I think, the face and the mouth. I think it was something random like the inner thigh were areas where there was convergence.
Okay.
But the answer is that absolutely. I mean, we live in a dynamic and fluid environment. So even just getting a dog in your house increases the similarity of microbiome between all family members that live in that house or all roommates that might live in that house. So there's certainly colonization that occurs that's shared from people that you live in tight shared spaces, particularly when it's a built environment, when it's not out in the wild and there's a lot of other, there's either diffuse nature or it's other microbial exposure. But in built environments, you do see this. In fact, there's a whole field right now, there's a company right now that's looking at the fingerprint of food, looking at the microbial fingerprints on food, and you can trace it back to a particular country or source of an origin, or
like tomatoes from Mexico. So interesting.
So their first track is actually looking at the traceability of food by doing a microbial sequence, so you can know if your food actually did come from here, if it's just a knockoff version of something else. I think it's a raw foods probably. I'm sure it changes. It doesn't persist once it's being mixed and cooked, but. It's this idea of traceability. I mean, we leave a microbial fingerprint everywhere we go, and it persists for a short period of time. I mean, people should even look up this idea of an exosome. It's this microbial cloud that is emitted off into the air around us that's unique and like a fingerprint to each person.
Oh my God, I've never heard of this before.
Yeah.
So like you're walking around with your aura of this microbiome that's unique to you.
Yep. And then another one that's kind of disgusting is if you go to public bathrooms and you look at the microbial dispersion based on a paper towel versus a air dryer system,
You're better off using paper towels, right?
Oh, any bathroom that has an air dryer is just filthy.
Oh man.
Yeah.
Because it just blows shit.
Blasted all over
You think
you.
it's cleaner because you don't actually touch or engage or touch in a particular surface, but microbes are being aerosolized. I mean, they're entering into your nasal cavity. Like, they're going everywhere.
Oh, I didn't even think about that. Oh my god.
It's super disgusting.
That's hilarious. So, before you came on our show, your company had sent some information to us, and one of the things that it said were common myths surrounding like probiotics.
Yeah.
And one of them I had heard originally from, we have a good friend of ours, Dr. Michael Ruscio. He's author of the book Healthy Gut, Healthy You. And we had him on the show, and he's the first time I ever heard this, that he said, when you take a probiotic, you're not colonizing your gut with it, which is a lot of probiotic companies will say, take this to colonize your gut. Give you, and you guys sent the same information, like, no, it's not. You're not creating a new colony of bacteria. There's different. You benefit from the probiotics through different mechanisms.
Yep. So you'll see, and it goes. There's 2 points to that story. So the first is, yes, you wouldn't expect to see. Maybe you'll see temporary colonization, but you won't. More importantly, you won't expect to see long-term shifts in the community structure of your microbiome, right? So if it's there on continuous consumption. I think some studies show that after they persist for 3 weeks, for 5 weeks, for 6 weeks, but then they'll wash out after you stop taking them. There's a lot of mechanisms by which they work, probiotic organisms work, and I don't want to defend all probiotics products that call themselves probiotic on the market, because I think most of them do nothing. Most of them are relics out of the dairy and fermentation and dietary supplements industry. They're very limited species, and they don't have randomized controlled trials on their strains. So when I use the term probiotics, I want to just say I'm not defending
all of them,
anything that claims to be probiotic. I'm defending specific strains and species of bacteria, which when you ingest can have a therapeutic effect in the body. And we know this. This has been tested in multiple trials. I'll go into some more of the research in a second. But yes, of all the mechanisms by which probiotics or the consumption of bacteria can improve health, colonization is one of them. It's only one of them. And that's only temporary colonization. So there's signaling with your immune system. There's the displacement of pathogens. There's the production of metabolites. There's changing the transcription patterns of the microbiota or the gut. I mean, there's neurotransmitter production. There's stimulation of, motility. So there's a lot of different ways by which these organisms can work. And by the way, I'm only talking right now on these species that have marketed themselves or exist today on the market as probiotics. That's like your lactobacilli and your bifidobacterium, of which probably 95%, the best they'll do is, if they survive, they'll produce a little bit of lactic acid. On the incredible side of things, they can do a lot. Some specific strains can interact with the gut, liver, heart axis. We have an area in our pipeline of a strain which actually was published in a randomized controlled trial, which had on average across the board in people with moderate to slightly elevated cholesterol, 14% reduction in LDL cholesterol, and in people that had cholesterol over 230, which is a high cholesterol group, 39% reduction.
Wow. That's
competitive with statins without changing host physiology.
Right.
So this is a mechanical mechanism. This is deconjugating bile acids, so your body doesn't stop production of cholesterol, or it doesn't affect these systemic pathways, right?
You said gut, liver, and heart axis?
Yes.
What is that?
So by that, I just mean those are the organ systems that it can affect.
Okay.
So the liver produces cholesterol, and bile, salts. And so those then get reabsorbed by the body in the end of the intestines. At the end of the small intestines, those get absorbed back up by the body to enter back into circulation. So the thesis here is, well, while those are out in the lumen, if these microbes can go to work mechanically and either absorb some of that cholesterol, into the membrane of that organism, or change it so it makes it more solubilized, so less of it is absorbed back into systemic circulation, then you can decrease LDL cholesterol, which, by the way, I know some people say that high LDL cholesterol isn't bad. High LDL cholesterol is still the number one risk factor for atherosclerotic events. So it absolutely is, the structure of it, the oxidation potential of it, and the effect that it has, particularly if you're at risk of a cardiovascular event, in multiple long-term epidemiological and intervention studies, shows that it's better. You want to rein in non-HDL cholesterol, so LDL and VLDL, and then also LDLP, which is the particle size.
Okay.
Particle number, sorry. But my point is that, just to go back to the point, there's a number of mechanisms that have nothing to do with colonization. The signaling to the epithelium to increase the expression of tight junction proteins, which is the mechanism by which it affects your barrier, that has nothing to do with colonization. In fact, if it's just already colonized in your colon, it won't have that effect because it's not in transit through the GI tract interacting with the epithelium, right? So there's a number of mechanisms that actually have nothing to do with
and it changes as it goes down through the body.
Yeah, absolutely.
And you want, another thing that you guys told us is you want them to survive through the body until it gets to the colon.
Well, you want them to survive. I mean, you want them to be metabolically active, right? I mean, there are some studies that show that inactivated or even heat shocked or sterilized organisms still have an effect in the body from a signaling perspective, because these, toll-like receptors, they capture the membrane and they recognize it, and then that results in kind of the body starting a cascade of events. But that's mostly immunological, right?
Okay.
All of the non-immune system-based effects are usually based on the survivability or viability of the organism.
And how do you guys ensure that, because it's not refrigerated or anything like that, how do you guys ensure that it stays alive through the body?
So I love talking about this refrigeration myth because it's, regardless of whether a probiotic product is refrigerated or not, it undergoes the exact same production manufacturing process. The exact same.
so refrigerating it afterwards doesn't make a big deal.
Oh, my point is that yes, some organisms or production methods are less sensitive to acute heat exposure, but across the board, you'll see that that's well above ambient temperature, and it's usually well above kind of acute heat. I'm talking over 100 degrees. I mean, there's some acute tests that even on our strains have been done that show exposure over 100 degrees for a couple hours at a time has a negligible impact on viability of the organism once it's produced. But for people that are interested, so what happens is you put strains into a biofermenter, and then you give it a medium and a broth that it starts entering into fermentation and a hypergrowth phase. Then once you've achieved multiplication of the organisms, you stop it. You stop the growth process. Usually there's a curve where you want to stop it before it kind of gets at too high of a yield, because then it has an inverse effect on viability. So there's part of the fermentation art is getting it to the part where you have viability but no alteration of the structure of the organism or of the semi-long-term viability of the organism. Then you freeze it, put it through sublimation, which is getting the water out of the frozen organism, but from ice straight to a gas form. So you skip the liquid phase. So you sublimate the water out of it, and then you you basically dry it, and that puts in a state of suspended animation.
Okay.
So more than heat, the biggest aggressor for organisms is water activity, because even trace amounts of water and humidity in the air can repopulate these organisms, so they become alive and kicking, and they're like, hey, where's some food or a substrate? We're ready to get to work, but they're sitting inside of a capsule, and then they die off really quickly. So that is the life cycle of any consumer or commercial available bacteria, no matter whether it's refrigerated or not. Why people say to refrigerate it is because they either haven't done the stability testing or as a safety precaution. But this idea that somehow it's more fresh or it's higher quality is a very kind of convenient truth or a convenient truism, because yes, it's true that these organisms there's no harm in refrigeration unless your refrigerator has a higher water activity level, in which case you want to make sure it's in a Ziploc bag or in some container that mitigates water exposure as much as possible. But it's not going to have any material effect. And in fact, the process is the same. In fact, I would say, I mean, very intuitively, you can think about it's kind of obvious when people think about this, they're mindset changes a little bit. But organisms aren't going to die from exposure because the temperature of the body is slightly a couple degrees warmer than what's circulating human temperature, 98.6 or so.
So if it can't survive in room temperature, how is it going to survive?
In fact, the temperature that you use for growth conditions, optimal growth conditions, if it's too cold, the organism won't grow. If it's too hot, the organism, is too comfortable, or it dies off from acute heat. So even in the fermentation process, there's a very narrow temperature band that's somewhere close to between 37 and 39 degrees centigrade, depending on the organism. And that's something that you do in biofermentation and scale-up testing. You try to narrow down on. The process is the exact same, irrespective of whether it's refrigerated or not. So I honestly don't get it.
What's your thoughts on the kombucha frenzy we're in right now?
Yeah, I think kombucha is a delicious beverage when it's low sugar. I think that there's not any studies that show that it's harmful for the body. It's a complex ancestral symbiotic relationship between bacteria and yeast. And I think it's delicious. And if you like the taste of a fuzzy fermented tea, the fact that it was fermented from tea, if it actually is of the original type, probably has some phenolic and tannic compounds that are beneficial for the body from a micronutrient perspective. There's a lot of acids that are produced that are pretty good, but it's not probiotic because in order for something to qualify under the scientific definition of probiotic, the product or the formulation or the strain needs to be tested in a double-blind, randomized, controlled human trial. That is the definition. And that was authored by our chief scientist in 2001 for the United Nations and World Health Organization. So the global definition of probiotics was actually authored by our chief scientist. Wow. And so one of his pet peeves is anything that has a microbial presence or is fermented calls itself probiotic because it's a marketing term, when the scientific definition is a microbe, a live organism that's shown to confer a health benefit to the human host. And implicit in that means that you have to show it in a randomized controlled trial. So that's my other pet peeve with kind of people that say, oh, well, probiotics are bullshit, probiotics don't work. I mean, kind of by definition, you have to have a trial
they have to be proven they work.
that shows that it does something in a randomized controlled setting in the human body. Otherwise, it's not a probiotic. So what these people are saying are fermented foods or bacterial products that don't have clinical trials can't claim clinical benefits. And we agree with that.
Yeah, you guys are definitely on the cutting edge. I think you guys have some of the leading scientists in all these areas of research. And you're also working on things that don't have to do with humans as well, right? Aren't you guys working on research for bee colony collapse or?
Yeah, so we have a division of our company called SeedLabs, which is our ecosystems, ecosystem and planetary health division. And I mean, if you think about the human body as having microbial or microbiome, then the Earth has one too. Soil communities. In fact, the two most complex microbial communities on Earth are in the human gut and in soil. Those are the most complex, concentrated, microbially diverse, and microbially rich communities of microbes, on the planet. And so we are very interested in the application of of bacteria and probiotics for a number of different areas. So we think human health, of course, is very important, but Fast Company wrote an article upon us when we announced our Honeybee program in the fall of 2018. And this is really, really interesting research. So unlike the human gut, the honeybee gut is very simple. There's 5 species that dominate it, right? A human gut, there can be over 180. And we showed that a couple things happen. So first, honeybees are dying all over the world. So it's a phenomenon called colony collapse disorder, and we think that it's happening from pesticides, neonicotinoid pesticides in particular. So as the name might suggest, these activate the nicotinoid pathway in the honeybee system, which of course is the same way by which the reward pathway is activated in tobacco consumption. And honeybees will go back to water that has a neonicotinoid pesticide in it more than they'll go back to water that has glucose in it.
Oh.
So these are incredibly disruptive to the physiology of the honeybee. It goes back in and they continue to go back
almost like they're addicted to it or what?
Yeah, sure. So it has a couple of effects. So the first is it disrupts their normal foraging patterns, and the second is it disorients them. So they have a hard time foraging and looking for food, and then coming back to their hive. So that's the first part, right? Is that and this was a Nature publication that our chief scientists group published. So the first one was actually in a model organism that showed that our organism, our honeybee probiotic, activates the detoxification pathways specifically for the detoxification of neonicotinoid pesticides. So our organism will go and serve as a buffer between those pesticides that may exist and the honeybee's immune system to detoxify prior to exposure interaction with the honeybee's system. So that's the first mechanism by which these works, and that was a really, really interesting publication. And then the second research, which is currently unpublished, and this was done in the lab of our chief scientist, Dr. Gregor Reed. And here we showed that the second aggressor for honeybees is a pathogen called Pentabacillus larvae, P. larvae for short. So this is the bacteria that causes American and European foul brood disease, which is such a nasty pathogen because its mortality rates are really high. But even more kind of emotionally heart-wrenching is it only affects baby bees in the first 3 days of life. So it kills off these young bees in large droves when they're first born. And so the second effect that our cocktail of probiotic bacteria have shown to do, and now this is in honeybee trials, is protect hives from that pathogen more so than a controlled hive. So there's two mechanisms by which our research track and our probiotics and honeybees work. The first is detoxification of neonicotinoid pesticides, and the second is in these pathogens that kill off young bees that can give a significant higher protective effect against, which fundamentally changes the population dynamics of the whole hive.
Fascinating.
Yeah.
How much you're getting a lot of interest, I'm assuming, in this because this could impact us in massive ways if we don't figure out how to remedy this.
Yeah. So honeybee, if we lose the honeybee, we lose humans.
Food. Yeah.
Yeah.
Yeah. Wow. Fascinating.
Yeah. What are we learning about the microbiome and sports performance? I mean, do you guys do a lot of research in that area at all?
Yeah, so the first, I think, most immediate. Well, I'll answer it in three ways. So the first is that to the extent that there's temporary or persistent gut barrier disruptions in performance athletes, which we know exists, and also GI issues are complained by elite performance athletes constantly, whether it's rigorous or intense training or disruptive travel schedules. It's one of the dominant areas. So kind of the lowest hanging fruit is the normalization of GI function. Is something that we think is very compelling. That's one of those kind of comorbidities we talked about earlier. The second is we talked about these detoxification pathways, particularly around oxidative stress. And exercise is as a pro-oxidant. One of the reasons why it's protective is because by temporarily or hermetically inducing this oxidative stress or this form of tissue-specific stress in the body, you then result in the activation of a lot of antioxidative pathways and detoxification pathways, which then systemically benefit the human body. So we know that that's one of the ways that exercise is protective, even in the short term if it's not so good.
To that point, I want to stop you right there. Do you think that there is a fine line of the intensity and the frequency that we train our bodies?
Absolutely.
There's got to be a sweet spot, right?
Yeah, absolutely. I think that this idea that harder is better, I mean, there's a number of ways where we could debunk that. Like we know that heavy weight, certain styles of weightlifting, they just rip up your they rip up your shoulders, they rip up your knees. I mean, the effect that it has on cartilage and the tissues that's in between bones. I mean, that you guys could comment on that better than me because that's not really my field, but I think that it's known for some time that there's a fine line between beefing up and the type of particularly mechanical stress that you want to put on specific systems versus kind of a more sustained, balanced, even distribution. You want to put muscle, but you also want to look at tissue integrity.
Yeah, in order to benefit from a hormetic response, you can't overcome your body's ability to adapt and become stronger. So you throw too much at it, you can't adapt to it. It's just going to overcome your body.
So that's on the host tissue side. On the microbial side, or from the microbiome perspective, I think, of course, you see these large scale disruptions, and then given the permission to hypothesize, and I always
yes, you got all the permission.
I always stop myself before then. So that's, if you do look at the evolutionary biology, I mean, there's very few, humans wouldn't be expected to kind of rip up or engage in this type of extreme chronic physiological stress for extended and chronic exposure in periods of time. I mean, you just wouldn't expect that, right? You'd have these periods of feast and famine. You'd have long cycles of rest. I mean, I think that part of the reason that humans are so lazy is because laziness is a protective mechanism from an evolutionary perspective. I mean, it doesn't make sense to just be
the other extreme,
chasing everything.
Right.
Yeah. One of my theories around why athletes have so many gut issues is you talked about earlier how high intensity exercise opens the gaps between the some of the cells of the gut, or makes it more permeable. And athletes have been taught for a long time to eat as much food as possible post-exercise because it does accelerate recovery. Yeah. But I feel like that's a perfect storm for developing immune, antibodies for food, because you get certain things into your bloodstream, your body's going to eventually identify it as a foreign invader, and you start to develop antibodies, and now you've got food intolerances or issues. Throw on top of that highly easily digestible or pre-digested processed things like protein powders right after a hard, intense workout. I think you have kind of this perfect storm of potential issues. Yeah,
so intuitively that makes sense to me. I think that probably the research would support it too if you dig for it, but from an evolutionary perspective, that certainly makes sense to me.
Yeah, interesting. So one other thing before we sign off, because you're a very fascinating guy, you wanted us to bring up your dogs, because you have you just got some new, but they're not normal dogs. They're like wolves.
They're what's called. Well, I mean, to the extent that people want to hear the story, I think I can give you guys the whole version. I don't even think we've talked about it yet, so you guys will really appreciate this. I mean, you joked about giving them woolly mammoth bones earlier, but I have a story that involves woolly mammoth fossils and these dogs.
Well, of course you did.
So I was in August. I was in the cold north, the Russian tundra. So this is north of the Arctic Circle. It's basically, people don't realize exactly how big Russia is. It dwarfs China, or starts basically, touches up against Europe, and then goes all the way over right across and looks over at Korea. So it's an incredible landmass. And it took just as long, if not longer, to get from LA to Moscow as it did from Moscow to the other side of Russia by plane.
Huge.
So I broke my journey in Moscow, and I was there with the Department of Genetics at Harvard Medical School. So I'm doing a lot of work with them right now, and one of my mentors and advisors is George Church, who's kind of a iconic biologist. He invented a lot of the gene sequencing tools and kind of the father of modern genomics, and has his own lab at Harvard Medical School in the genomics department there. I spent a lot of time there. And so he's working on a project that you guys might have heard about recently, because it's crazy.
Is it the Jurassic Park one where they're bringing them back?
Yep. It's the
What could go wrong?
De-extinction of particularly the woolly mammoth. And so when the first question people always ask me they will say, so are you saying Jurassic Park is possible? No. DNA degrades after around 500,000 years, so it doesn't matter if it's preserved in amber or resin. That's the first kind of, not to ruin everyone's childhood dreams. That's the first
I wanted a pet raptor.
Yeah. But we can make estimations as to what the genome of those traits that would be found in existing animals that would reconstitute that genome.
Wow, like crossbreed them?
You can never bring it back, but you could rebuild from scratch what you think. That's what synthetic biology is, right?
Okay.
It's the idea that you can use genomics and use the genome as a platform for biology. And so I was there doing some work with them because, it started when I was just in George's office. And I found out that, for the month of August, for 3 weeks, his admin said that, George isn't taking any meetings. He's going to be gone. And that's a really ominous thing. So I was like, well, where is he going? Like, well, it's really top secret, but, he's going with a camera crew and, the Koreans, there's kind of a race right now. So there's two ways people are using to bring back the woolly mammoth. One is through finding the genes that are found in the mammoth and then editing the genome of the Asian elephant and then transplanting that edited embryo back into an Asian elephant to make that elephant give birth to a woolly mammoth. That is the first path. And I think that's probably the easier and better path, right? And the second is what the Koreans are doing. And if you remember, there's a huge scandal with all the cloning research, or most of the cloning research in the world is happening in Korea right now, where for like $100,000 they'll clone your dog, right?
Oh yeah, I've heard about that.
And there's a lot of ethical concerns with that because the efficacy rate's really low. I think 1 in 2 out of 8, for instance, work. And cloning is a much different process than genome reconstitution. So those are the two ways that people are targeting it. And while we were there, the Koreans were there doing their research at the same time. So the space is heating up right now. But we went because this isn't just a let's play God or we want to just use biology as a platform for magic or to do things just because we can. There's a really interesting theory to this, and the theory is that there used to be hundreds and hundreds of thousands of mammoths that used to roam the earth. Not just the woolly mammoth. That was just one variety. There was the Colombian mammoth. There was the North American mammoth. I mean, these big related relatives of the elephant were all around the earth. I mean, and one thing about this, kind of to tie it back to the comment you said earlier about how food and fruits used to have these big seeds on the inside. Yeah, there's a study, no one could figure out from an evolutionary perspective what the avocado was made for. We all love it because of its fat content, but with that big pit that's indigestible to most animals, and if you think about the thesis of these foods is they want to then be excreted out to then grow again. And I mean, what could eat that, right? And so they said it's some relative or some closely related ancestor of bridge species between the elephant and the mammoth that absolutely loved it. And so that's a funny backstory for avocados. But yeah, these mammoths used to be all over, and particularly on the mammoth steppe. And so that's that region which is up in the northern area of the tundra. And the tundra used to not be this barren ecosystem. It actually used to be a grasslands. And so the Russian group there that's been doing research on this area for soil temperature and ice temperatures for over 30 years, they find that in the summertime, these Pleistocene era grazers, so this is these reindeer, these giant moose, and of course the best and boldest of them all was the mammoth, would punch through the top, allow these grasses to temporarily poke through, which have twofold effect. The first is that tilling of the topsoil keeps lets that cold air come down and keep the surface temperature cool instead of packing it in. And the second is they prevent trees from growing, which, how counterintuitive is that? That trees are actually bad because they absorb heat and they are what's called unproductive in that ecosystem. They don't have any nutritional value and they take resources, whereas grasslands are the most productive ecosystem on Earth. And so the thesis was, if you can reintroduce these areas, you can make this ecosystem flourish again. I mean, we glorify it saying, oh, well, the tundra should be icy because that's what we grew up thinking. But this should be a rich grass. This ecosystem deserves and should and was, at least seasonally, a grassland.
So they're thinking, we're going to make woolly mammoths so we can put them out in the tundra and make it.
So they're saying if we can reintroduce these Pleistocene era grazers and very efficient ones onto that system, we can decrease the surface level, and they've done these 2 studies. I mean, I've seen the data where there's as much of as 17 degrees Celsius in difference from the areas where they've reintroduced grasslands versus the ones that exist today, and the temperatures are remaining stable there, whereas they're getting warmer and warmer in the tundra, right?
Interesting.
And so why is that important? Well, of course, any good movie needs a save the world story, and so locked under the tundra is more carbon than an aggregate, all of the impact that humans have had with our carbon utilization and methane production over the last 100 years in the fossil fuel era. So the idea that it's a ticking time bomb that's under there is that carbon and that methane becomes aerosolized by bacteria if we melt it enough where those organisms can become out of their dormant state and become active again, become metabolically active. And
not good for the climate.
Not good for the climate.
Right.
I mean, we don't know what that type of a shift would do. It could catalyze our... Let's put it this way. In the most extreme circumstance, it could, all the other stuff we're talking about right now, 2 degrees here and there is absolutely nothing compared to what would happen if all that carbon gets unlocked.
Just superheat everything.
So that's the motive behind it, and the idea is that it's an elegant story. It's a way that we can use. I'm very interested in de-extinction personally. I think that it's one of the areas that I want to spend the rest of my scientific career in.
So how does this relate to your dogs?
So here's the story with the dogs. So we landed in Yakutia, that's on the eastern side of Russia. Then we took another 6-hour flight, and at this point we're all the way up in a polar town called Chersky. And this is right on the rim of the Arctic Circle. I mean, it's so close to Korea, it's almost looking at Alaska. And then we got on a river barge and went 18 hours up the mouth of the Kolyma River into the Arctic tundra. And that's where we were gathering sediment samples, mammoth bones. I mean, I came back. I have a woolly mammoth jaw that I found and uncovered, and I smuggled back overseas with me.
Nice.
Hopefully there's no Russian authorities listening to this. But I brought these, and it's so rich. I mean, when after a rain, you'll see these 40,000-year-old fossils washing up onto the beach. I mean, you can walk up and down the beach and just pick them up.
Wow.
Whoa. Yeah, that's crazy.
So that shows you the biomass that existed at that time of these animals and how much of it is under and unearthed. And when a storm or an event occurs, it literally just washes up. I mean, we were digging a little bit, but primarily we were just walking on these hotbeds in Divani Yar, right? That's the area that we're at. So we go do that trip. We come back to the science station. It's called NES. It's the Northeast Science Station. It's the northernmost science station in the entire world. And it was a Soviet outpost during the Cold War. And abandoned, and there's no other town. I mean, the closest town is tens of miles away. I mean, there's nothing around here. And abandoned under that science station were 2 between 3 and 5 week old puppies. And they had burrowed and tunneled in underneath the science station. And they were living amongst like cinder blocks and nails and just all of the excess kind of waste from building this giant satellite dish.
So you just found them there.
So these are wild dogs. These are primitive dogs. And the only dogs, so primitive dogs is a term that describes dogs that existed prior to human domestication. So all people will say like, oh, so I have 2 of them now. Their names are Luca and Sasha. People will say like, oh, well, Sasha looks like a German Shepherd. She must be a German Shepherd. I'll say, yo, Sasha predates German Shepherds as a species, as a strain of dog, if you will.
Well,
so
if it's pre-dog, it's like pre-Germany.
Yeah,
Before Germany existed.
Absolutely. So we don't know the history of these wild dogs, right? They don't have traditional domestication. They certainly don't live in a house in Los Angeles or never lived in a residential community. Usually, what you get to see with them are these types of relationships. Why? I mean, it's like looking back in time. It's why these dogs are so special to me, because you see the kind of innate bond that this animal has and coevolution with the human species. That's incredible.
So do they act like normal dogs, or are they different?
I mean, I've raised a wolf dog before. So I had to use some very I had to use every training trick in the book that works with them. That first, they don't respond to negative incentives at all. Punishment just does not work. Everything has to be incentive based. If you punish them, then they start to associate you with those feelings of punishment because they don't have an innate understanding of whatever you're punishing them for as being the catalyst for that negative reaction. So they end up expressing overall levels of fear around you
if you punish them,
an unpredictable fear, and maybe they'll associate it with the action that they've done, but not enough to change the behavior, right? Unless you catch them in the act. So if you're potty training them and you grab them and you stick their nose into poop and punish them, they're going to have no clue what you're trying to say to them. But if you give them a negative reinforcement when you catch them in the act indoors, for example, so you have to kind of keep them on 24-hour surveillance and catch them every time while they're doing it. Otherwise, they'll never understand. You can't do it after the fact. And I think that persists to more breeds of dogs than people think. They are very hierarchical. And so they don't have a willingness to please humans in general, but they will respond to authentic and strong leadership. And so you can't ever be, I know it sounds very kind of like Russian bravado, but you can't be, show weakness in some areas around them. Like you have to lead by example.
So when you're sad,
you gotta be a true alpha.
Yeah. Well, that term is just, I think so commoditized and used, but I think that they win your respect as a leader, and then they orient themselves around that role or have no expectation that they're going to listen to you. So you can't have it both ways, right? So I would have to do some things like, like when I was pouring their food out, like hold them back by the collar and pretend to eat out of their dog bowl and make them watch for a certain period of time.
My food.
That I get to go first. You never give, the one rule with them is you never give them anything for free. So anytime you give a reward or incentive, you have to make them work or reinforce commands or reinforce tricks. But I bring that up to say, now they're perfectly trained. The whole suite of, they'll do anything. The only thing that they won't do, or what oftentimes you find with dogs, or the way that they rank dogs, are based off of their responsiveness to a command and willingness to please. And so some of these really intelligent dogs, they'll eventually do what you're telling them, but you either need an incentive or you have to tell them 3, 4, 5 times. So they'll never really respond unsolicited to the first time you give them a command. That's just something that you gotta deal with when you get an intelligent dog. But in terms of domestication, now they act really domestic. The first time I was interviewing a dog sitter, somehow in the middle of Venice, Los Angeles, in an art lofts community, on a 6-foot leash, Sasha found a mouse. I don't know how. And I was like, oh yeah, these dogs. I didn't want to tell any dog sitters the true story because I thought I'd scare them all away.
Yeah.
And so Sasha comes back with a mouse in her mouth, super excited. I'm just like, where did you get that? Where did you find that? How? Apparently it was under the couch or under the sofa. I got evicted from my residence because I live in the side property on a horse ranch. That has a couple of horses and a pony and a couple of chickens, and I got evicted. Ended up getting unevicted because Luca snuck in there and just totally snagged a chicken. Like she went for it. There was nothing that could have stopped her. For weeks she was eyeing it from the outside of the coop, and the minute the horse keeper left the gate open, she knew what she wanted to do. She got in there. She fucked with it for a little bit, and then it slowly bled out and died over a short period of time.
You have to eat the chicken in front of him to show him who's boss.
If I were to reinforce that behavior, I would say yes, but I can't reinforce that behavior.
Yeah. How are they around other dogs?
They're very curious.
Okay.
So they're of course excited that it's closer to them than a human, and they're eager to go and explore it. But they'll lose interest very quickly.
Interesting.
Yeah.
Well, that's a very fascinating story, man.
So, but the good news is I have them for life now. So, I'll send you guys a picture. You can put it up in the show notes. But they're super wool. They don't look like domesticated. They don't look like normal dogs. Yeah.
Oh, that's rad.
Yeah.
Well, awesome. It's been a pleasure interviewing me.
Yeah. Thank you guys for having me. This was really fun.
Really, really great conversation. Very fascinating individual. I think what you guys are doing is you guys are on the cutting edge. That's what got me excited about meeting with you and working with you guys, is that you guys are literally some of the leaders in the field of research in the microbiome. And I think personally, like I said earlier, that what we're going to learn about the microbiome and how to alter it and how to supplement it is probably going to be some of the biggest breakthroughs that we're going to see in biology in the next 10 to 20 years. So
well, I appreciate you saying that. And for anyone that's listened all the way to the end, I think that one of the reasons why I get up every day and why I'm really, really excited, and certainly all of our scientists, many of which have never attached themselves to a consumer health or a life sciences company before ever, are working with us, is because, we really take a hard science approach. And we try to do it across a number of different organ systems in the body. So, of course, our first product is a collection of strains which have really, really robust clinical data behind them. So for a number of different organ systems in the body. So whether it's digestive, the first thing you'll expect to experience from our first product are noticeable and visible improvements in digestion, from number of weekly bowel movements, to barrier integrity, to stool consistency, intestinal motility, ease of expulsion, anal itching. I know it's very graphic, but these are the endpoints that were studied in clinical trials. But we, as a company, we have a lot of research areas and tracks that over the next couple of years, you guys should really, hopefully, are interested enough to follow along with.
Absolutely.
So our next big research track is in how we can make sugar healthy. And that's kind of a really big idea, but you can use microbial enzymes to make fiber have the sweetness profile of sugar.
Oh, wow.
So there's nothing inherently wrong with sweetness. The problem is just that it's too easily available and accessible to the body. And then when there's too much circulating glucose, or there's too much of an insulin response, long term, that's really bad for the body. But what if you could have a fiber that had the sweetness profile of sugar?
Interesting.
We're going to have a lot of big announcements this year about that.
Protein bar companies will be all over that.
Yeah, so I think everyone's going to be all over it, but we want to be really thoughtful about how we bring it out, and do it in a controlled way.
Excellent.
And then, of course, you guys got some glimpses on some of the other stuff that's, for women listeners. Next year is going to be our year of the woman. We have a lot of technologies that are directly based on and developed by $10 million, 10 plus years of research, $20 million of NIH funded research from a specific lab. The scientists that led this site for the Human Microbiome Project, for the vaginal microbiome. And then we have some really exciting stuff working on skin, both from the microbe standpoint, but also host response, aging of that tissue, and how specific microbes can address and prevent that tissue specific aging. And so, as I think that if people almost ask me, how would you want to describe seed to your friends, or how would you describe seed to other people? I would say that in the future, microbial sciences and microbes are going to change and disrupt a number of categories, certainly related to products that we buy today. And then the breakthroughs are not going to come from a company. They're not going to come from a Pfizer or a J&J. They're going to come from popping up at different labs that have domain expertise in that one skill set, and have been doing it for the entire life cycle of that lab, right? And so what we've built is an organization, an ecosystem of scientists, doctors, academics, lab leaders, government employees, and
you guys have an amazing
a huge roster, that brings that research integrally from bench all the way to shelf. And so, I think the next couple of years is going to be really exciting. And we have a lot of really big stories that we want to tell too. So if you like the content, if you like the products, a lot of people have tried our first product and they said it's fundamentally changed the way that their a lot of digestive complications have gone away, but just fundamentally changed digestion. I think most people don't understand that 68 million Americans have chronic constipation. That's like 10x all digestive diseases combined, right? Mm-hmm. And so certainly a lot of people that turn to health for the first part, that's one of the areas that they feel it so visibly. So that's what we're working on.
Excellent.
And we're really excited about the years ahead.
Appreciate it, man. Thanks for coming on the show.
Thank you, guys.
Thanks,
man.
Thank you for listening to Mind Pump. If your goal is to build and shape your body, dramatically improve your health and energy,
and maximize your overall performance, check out our discounted RGB Super Bundle at mindpumpmedia.com. The RGB Super Bundle includes MAPS Anabolic, MAPS Performance, and MAPS Aesthetic. 9 months of phased expert exercise programming designed by Sal, Adam, and Justin to systematically transform the way your body looks, feels, and performs. With detailed workout blueprints and over 200 videos, the RGB Super Bundle is like having Sal, Adam, and Justin as your own personal trainers, but at a fraction of the price. The RGB Super Bundle has a full 30-day money-back guarantee, and you can get it now plus other valuable free resources at mindpumpmedia.com. If you enjoy this show, please share the love by leaving us a 5-star rating and review on iTunes and by introducing Mind Pump to your friends and family. We thank you for your support, and until next time, this is Mind Pump.